Hello, so today we're going to be talking about rhombuses and rectangles mainly, a little bit about parallelograms. So if you remember from our last section, a parallelogram had to have a few different qualities in order for it to be a parallelogram. So if you can't remember these, it might be a good idea to write these down so you can pause the video every time I say something and write it down, make a note of it. But a parallelogram has to have opposite sides be congruent. Opposite sides are also parallel. So if I have a parallelogram, opposite sides are congruent and parallel. These two sides are congruent and parallel. Also, the opposite angles need to be congruent, and the consecutive angles have to be supplementary or add up to 180. So we are going to need to know that for the definitions that we give for rhombus and rectangle. So a rhombus, it has all the qualities of a parallelogram plus all four sides are congruent. So this rhombus here is a parallelogram, but it's a parallelogram that happens to have all four sides congruent. So that's what makes it a rhombus. Now, a rectangle is also a parallelogram. So it has all the qualities of a parallelogram, except the opposite sides, or excuse me, all the angles are 90 degrees. So here's kind of what we just talked about. So rectangles and rhombuses are also parallelograms, so they have all these properties. And one that I forgot to mention is that the diagonals bisect each other. So if I draw a diagonal, they bisect each other. So remember that when they bisect, that means they create, let's use a different color here. They create congruent sides because they cut each other right down the middle. Same with the rectangle. They also have bisecting diagonals. In a rhombus, the diagonals are perpendicular, and not only do they bisect each other, they also bisect the two angles that they touch of the rhombus. So if these two diagonals are perpendicular, remember what it means to be perpendicular. So when two lines are perpendicular, they create 90-degree angles. And since this diagonal is also bisecting this angle right here, this angle and this angle have to be the same. This angle and this angle will also be the same. This diagonal is also bisecting this entire angle right here. So these two angles would be congruent as well as these two angles. So in example 1, ABCD is a rhombus. Find the measure of each numbered angle. So if this is a rhombus, remember what we just talked about for rhombuses. So we know that the diagonals bisect each other, which creates 90-degree angles because they're perpendicular, I should say. We also know that this diagonal bisects this angle. So angle B is getting bisected by this diagonal. So that means if this is 62, this has to also be 62. Since this is a rhombus, and a rhombus is the type of parallelogram, opposite angles have to be congruent. So if this is 62, both of these are 62, then on this side, both of these will have to be 62. So I know that angle 1 is equal to 62 degrees. The measure of angle 2 is equal to 90 degrees since these two are perpendicular. So now we have to figure out angle 3 and angle 4. So if you remember, one of the properties of parallelograms is that consecutive angles are supplementary. So I know that angle A, so this entire angle right here, and angle D have to add up to 180. You could use angle A and angle B, it doesn't really matter, just two consecutive angles. So angle D is made up of two 62-degree angles. So if I add those two together, I get 124. So angle D is 24 or excuse me, 124 degrees. Measure of angle D is equal to 124 degrees. So that means angle A has to be supplementary to 124. So 180 minus 124 would be 56. So the measure of angle A has to be equal to 56 degrees. But remember, it's being cut in half. So each of these halves would have to be half of 56. So 56 divided by 2 is 28. So that means angle 3 is 28 degrees. So again, opposite angles of a parallelogram, or a rhombus in this case, are congruent. So these would also be 28. So the measure of angle 4 would also be 28 degrees. So that's example 1. Example 2. This shape is a rhombus, so we got to find the measure of each angle. So if it's a rhombus, I know that the two diagonals are perpendicular lines, so these are all 90-degree angles. So angle 1, the measure of angle 1, is going to be equal to 90 degrees. This angle right here is 30 degrees. So that means this angle has to be 30 degrees because diagonals bisect the angles that they touch. Since it's a parallelogram, a type of parallelogram, the opposite angles have to be congruent. So if these two are 30, these two are also going to be 30. So we got angle 2, angle 3, angle 4. So angle 4 is going to equal 30 degrees. So then I recommend pausing the video and seeing if you can figure out angle 2 and angle 3. So to figure out angle 2 and angle 3, we know that consecutive angles have to be supplementary. So this entire angle right here is 30 and 30. So this entire angle is 60 degrees. So if this angle is 60, this one has to be supplementary with 60. So this entire angle will be 120 because 120 plus 60 is 180. But we have two halves of 120, so each of those would have to be half of 120. So this would be 60 and then 60. So that means the measure of angle 2 is 60 degrees. And since opposite angles are congruent, these also have to be 60 as well. So angle 3 is 60. Now moving on to the next page. So again, the following shape is a rhombus. So you got to find the measure of each angle. So I recommend pausing the video and seeing if you can do this on your own. So these are all 90 degrees because the diagonals of a rhombus are perpendicular. So that means the measure of angle 2 is going to be 90 degrees, as well as the measure of angle 3 is also 90 degrees. And then we got to figure out angle 4 and angle 1. So this right here is 27 degrees. Diagonals bisect the angles they touch, so this has to also be 27 degrees. So angle 4 is 27 degrees. Opposite angles are congruent, so these are both going to be 27. So angle 1 will have to also be 27 degrees. So now we're going to move on to rectangles. So a rectangle, the diagonals, all the diagonals are congruent. So all 4 of these are congruent, or you could say all 2 of the entire diagonals are congruent to each other. So that's going to be important to know for the next couple examples here. So WXYZ is a rectangle. So hopefully we all know that rectangles always have 90-degree angles on all 4 of their vertices. So we got to find the measure of ZY. So notice we know what WZ is. We know that this length right here is 10. So this length would also have to be 10 since those are congruent. So I know the length of this blue side and this blue side. So we're trying to find the length of this right here, ZY. Notice that blue shape that I just drew is a triangle, a right triangle. So this length would be 12. I got 10 and 10. So 10 and 10, that would be 20 altogether. And we're trying to find this. So if you have a right triangle with two sides that you know and one missing, you can use the Pythagorean theorem. So a squared plus b squared equals c squared. So 20 is the hypotenuse, so that has to go in c, so 20 squared. 12 squared, doesn't matter where it goes. So 144 plus b squared is equal to 400. Subtract 144 on both sides and we get 256. So take the square root. The square root of 256 is 16, so b has to equal 16. So zy equals 16. Example 5, find the value of the numbered angles. So again, we know that these are all 90-degree angles because it's a rectangle. So the measure of angle 1, if this is 40 and this entire angle is 90, then 40 plus what equals 90? Well, that would be 50. So angle 1 is 50 degrees. The measure of angle 2, so again, same thing. If this is 50, what does angle 2 have to be for them to add up to 90? So, or 90 minus 50 is 40. So now angle 3 and then angle 4, those are a little tougher, but not too bad. So we know that rectangles have opposite sides that are parallel. So these two lines are parallel to each other. This line, this diagonal right here, is touching both of these parallel lines. So that is called a transversal. So if I look at angle 40 right here, angle 4 is an alternate interior angle with angle 40 because they're in between these two lines. These lines are also parallel. And they're on alternate sides, one's below, one's above. So this has to be 40 degrees as well. So then it's easy to figure out angle 3 because they have to be complementary. So angle 4 is 40 degrees, angle 3 is 50, and we are done with example 5. So then I just have a little closure quiz activity for you. So for each one of these, decide whether the statement is true always, sometimes, or never.